In this video, I'd like to cover some of the ideas behind what it means to pass something by reference or by value, and also cover the idea of what a pointer is. So I have this piece of code over here that has four different functions that I've created. I have one that's called just a basic int, where you just pass it in. One which has this ampersand, which means that you're passing it in by reference. This one's by value, this one's by reference. And then I have two that involve pointers, which is this little star symbol here. So this is saying this is an int pointer being passed in, and this is an int pointer passed in by reference. Generally speaking, what's going on is that anytime you see a star, that means it's a variable that is pointing to some other address in memory. And whenever you see the ampersand, we're talking about the address of that variable, so where in memory that address is located. So in this sample piece of code, I've got this local variable here, which I have named cleverly local var, which is a 2 right now. And then I have a pointer that points to the address of that. So now this thing is pointing to the memory location of this variable. And I can actually alter it, this local variable, using the pointer. And I'll get to that in just a sec. Things that I've got here. So there's this local variable that I'm just printing out, the pointer where it's at, and then I have its address in memory. So if I run this real quick, so now we see that the local variable is 2. The pointer, which you use this syntax with, is also 2. And then this is the address in memory. This is a hexadecimal number of where it's located. So the star here means go to that location in memory. So go to where the local variable is and use that value just like you would an int. So whenever you see the star in front of something, that's a dereference. So the pointer is pointing to the local variable's address, and we can use the thing in that spot by using the star just in front of the pointer. There's another syntax we'll see later on, which is an arrow, which involves classes and structs, but for now know that that goes to that location in memory and then treats it like a normal variable. So the next thing I have here is an int by value. So down here, I've created this parameter. The parameter here is a copy of the local variable number 2 here. So this is a new variable named param variable, which now has a value of 2 copied into it. They're actually at 2 different locations in memory. So here, if I see the parameter and then change it to 3, and then what it is afterwards, so that's located here. It starts off as 2 because that was copied in. It's now a 3. But when I jump back out of it, so after the int by value, notice that the local variable itself hasn't changed. I changed this parameter here, but that doesn't alter the variable that it was called from. However, when you do int by reference with this ampersand on it, you're actually passing the location of the actual variable into the function. So here, int by reference, before that, it's a 2. I change it within the method. It's now a 4. And then when I jump back out again, so after int by reference, notice that local variable is also a 4. So it actually changed the original value of the variable out here. Okay, so now the more complicated thing. So if I pass in the pointer, so I pass the pointer in to this parameter here. So the pointer is an address in memory. I mentioned that. It's this 4F, CBFC. That's the location in memory. The parameter right here has a value of 4 when you dereference it. And the parameter address is that same place. So I'm altering the original thing. I change it to a 5, and then if I create a new pointer, which is what this is basically doing, creating a new integer, notice that actually changes the actual address here. So this is the parameter's new address, but notice that that doesn't change the pointer back out in our main section of code. So I've altered the parameter to have a value of 5, like where it's pointing to. So I've actually altered the original local variable out here. But now if I change this parameter to a different value, I haven't altered the original pointer. Now, this was pointing to the address of the local variable. I am actually altering the original local variable. So I changed this value to a 5, as you can see here. But I didn't change where the pointer is located. It's still pointing to the same spot. Now, that is different than this guy here. This one I'm actually passing the original address of the variable into the method. So here the parameter comes in at 5. This is its address. I change its value to 7 here, and then create a new integer, 8. And notice now that its address is this value, the 6000228D0. And then when I go back out here to where my original pointer variable was, I've actually altered that. So, long and short of it is, by value, you make a copy of the original and pass it in. So here, this is a copy of the integer. This is a new copy of the pointer, though it is pointing to the same spot, and you can alter the original. When you're passing in by reference with this ampersand, you are passing the actual variable in. And if you alter it within the function, you are altering the original from out here. And that includes with pointers. If you need to change the original pointer, you can actually change that here. This becomes useful when you're not allowed to use global variables, which you're not in C++. For example, if you have some sort of pointer to like a room in Zool, and you need to alter where the current room is within a function, you want to pass that in by reference, because then in your actual method, you can change the original pointer's location. If you just need to alter the value that it's pointing at, then you can just pass it in by value and change the original value there. Hopefully that helps clear up some of the things involving pointers and reference and value.